Hello everyone, in today's video I will show you how to use Numpy library. We need Numpy library because if you use Python's default arrays, for example, let's say my array equals 1, 2, 3. And imagine that you want to implement some algorithms, add some functionalities, just multiply it maybe, okay? You just want to multiply it by 2, for example. It's not very useful with Python's default array system. You can see here, you can print my array, and you can see that it basically copies elements and add them for our example 2 times. So it doesn't quite multiplies the array in the way we want. That's why first need to import Numpy, of course. Let's import it. Import Numpy. By this way, we import Numpy library. We write as NP so that every time we write NP, we actually refer to Numpy so that we don't need to write Numpy each time. So let me run this. And then we can say my NP array equals. We can create NP arrays in several different ways. For example, we can do np.array. And here we can write our array like 1, 2, 3. Or if you already have an array, my np array 2. Or if you already have an array, in this case we have my array, and we want to transform this to a numpy array, we can do np array this, and then we can print them, right? We can print my numpy array and my numpy array 1. Let's see them. As you can see now, these are numpy arrays. The first one is we created and the second one is equal to my array. For now we're gonna use this my numpy array here. Actually, let me create another array. By the way, you can see this is a numpy array by printing its type. Let me also show it to you. Type my array, my numpy array, and let me also print our Python array. And now we can see one is list because list is Python's array type, and other one is numpy and the array. We're gonna use that one for our tutorial, this tutorial. They are very useful for matrix applications, machine learning algorithms, maybe some AI solutions. So you will see Numpy a lot, I think, if you're gonna use Python. So let me create another array. Let's call it array1. Array1 np.array, and here we're gonna create an array which has 2 dimensions, okay? 2, 3, and then we're gonna put comma here. Okay, its shape will be 3 by 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here, wait, I forgot this one. So now our array is actually not 1-dimensional, it's 2-dimensional. These are rows, as you can see. Can I just go down? Okay. These are rows and these are the columns. You can see your array's shape by print array1.shape. As you can see, it's 3 by 3. We can also make it different. We can add one more row if you want. 10, 11, 20. Now it's 4 by 3. And you can also print its dimensions. My array, not my array, sorry. Array.1 and the number of dimensions basically. And as you can see, it's 2 because it has rows and columns. You can of course make 3, 4, 5, 100 dimensions too. And we can manipulate this array. I think you probably know list. If you don't know, you can watch my previous video or any video you want which explains list in Python. This is like a list. It's very similar to x is a variable, but in list you want to achieve 5. Okay, you want to get this element. In Python you will do, let me print this, or not print, but number equals, in Python you will do 2 and 1, sorry, 1 1. In Python list, this one means rows. Okay, it goes first row and second row, 0 and first index, and then this one goes 0 and first column. So this will get 5 to us. Okay, but in Numpy you can just use one parenthesis and put comma, and then you can print this number. As you can see, it's 5. So in Numpy you can get variables like this. You can also manipulate them. You can do array1 equals, array1, this element equals -5. Then you can print array1, and as you can see now it's -5. Let me clear this and run this again, so our array is not lost. It's same. Okay, you can also, for example, you want whole row. What you can do is you can do something like this. You can print this one. Oops. As you can see, this means start from the first column, first row, sorry, as I said, this is row, and print all of it. Basically, because we don't say anything about columns, right? We just say start from the first row. So the 0 index, the actually first row, is not in the output. You can also do, oops, sorry. You can also do 0, 3, and 2, for example. So this 2 here means step size. Okay, this is start of the row, this is the final row, 3, but it's excluded. Here we didn't write anything, that's why it goes until the end, but here we say stop on 3, don't include third one. And step size is 2. If you don't give a step size, it's by default 1, but now we say 2, so it will start from 0, and it's included 0, but it won't write this one because step size is 2. So it will ignore this one, and it will print this one, and this is third index, so it won't print this one. Anyway, we have step size of 2, so even though we entered 4, it wouldn't write this 2, but you get the logic, I think. As you can see, it wrote in the output this and this row. Let me also deal with columns this time. As I said, this is row, so we want all rows. Okay, we just put this one. We say start from beginning, end at the beginning, and we don't give a step size. By default, it's 1. Now we want to care about columns. Let's say start from first column, and then I don't want to give step size or anything. Okay, it's just first column, so this column will be disregarded. As you can see, it's only wrote these 2 columns. The first column ignored because we wrote it 1. If you wrote 0, it will print all of the array. And also, if you want all of it, you can just leave it empty, because by default it's 0, always 0. And these were some operations that you can apply in NumPy arrays. As I said here, you couldn't multiply Python list with 2, I mean a number. Okay, you couldn't multiply it, or you couldn't add something. But in our case, operations, we can apply some mathematical operations like multiplying by 2, or adding, for example, 100, or we can even take a square of our array, or we can do print. We can use NumPy's square root function. This is very easy. If you need to apply square roots of something, you can use NumPy's default square root function, and here inside it you give your array like this. So first it will multiply each one by 2, each element. It won't just copy paste the same array like in Python. As you can see, first it multiplies each element by 2, and then it multiplies each element by 1. Oh, I accidentally done this. So let me create again the list. I want to print my array. Okay, and now as you can see it multiplies by 2 and then it adds 100 to each element, and of each element, as you can see, since these are integers, they are not floats, the array elements look like this, and then here it take square root. When we do apply these operations, they don't affect the original numpy array. Okay, when we do this, it just prints the array in that way, but if you really want to multiply your array by 2, you need to say my new array, for example, and then multiply it by 2. And now it's changed, but just applying operation and doesn't assign it to anything, it doesn't affect your original array. We are just printing now, and here you can see every operation that we applied to our original array. So let me print our array again to see. You can also multiply or add two arrays. For example, let's create array 2. Or let me create like this. Let me create array 2. Okay. Array 2 equals our array 1, but for each element we add 100. So let me print array 2 so that we can see in the output. So we have this array and this array, and now I want to subtract my first array from my second array, so that we get 100 for each element. So you can do subtraction very easily with Numpy. Also, you can add them, multiply them. There is also filtering in Numpy. Print ages lower or equal to 18. It just automatically filters the array. It searches through the array and it finds elements which are lower or equal to 18, and it will print them. Not the elements, but the results of this Boolean expression. Okay, so it writes true, false, false, true, true, false, false. As you can see from the our Numpy array, it's correct. So you can do this filtering, and you can say, for example, you want to change ages which are lower or equal to 18. You can say, for example, ages, and inside ages you say I want to change that element. If it's lower or equal to 18, make them, for example, -1. And let me also print now our new ages. Print ages, and now as you can see our list, if it's lower or equal to 18, we make them -1. For example, you can play with the data, your samples. You have a data set, you can detect outliers and modify them in the way you want, basically. And now I will show you the broadcasting thing in Numpy. As you remember, we summed up two arrays, but they were in the same size, same shape, I mean. And now I created two arrays. This one, as you can see, I didn't do something like this. Not like this, okay? I put two parentheses, then inside the second parentheses I put the numbers. That's because I wanted to create two-dimensional array, okay? If you just do something like this, it's one-dimensional, right? It only has a row. You cannot add another row. It doesn't have any columns. It's just one-dimensional. And if you have an array which looks like this, then you can access any element using this method, like array and index. But I wanted to create two-dimensional with rows and columns, so I put another parenthesis and I filled it. And this is our first row, and we don't have any rows. If you want other rows, you can, for example, do something like this, if you remember. But I just added one row and I printed it here. As you can see, this is the array, and I created another array which has 1, 2, 3, 4, 5. Each row has one element, and it has 10 rows. So the difference between arrays is that one has one row and 10 columns, another one has 10 rows and only one column, and they look like this. So can we sum these arrays, or can we multiply them? Can we apply any operator on them? Yes, we can, because Numpy has broadcasting thing, which allows you to perform some operations on arrays which has different shapes, they can expand dimensions so that the dimension match with the larger array's shape. So it basically expands the smaller array, then it can apply some operations on it. And now we will see multiplication. Let me first run this. Oops. Okay. And let me apply this operation, for example, and print it. Let me also print these two uncommented. This is our first array, and this is second array. We want to multiply them, right? So there are two conditions that this would work. First one is the arrays, they have the same shape, then it's easy. But if arrays, they don't have the same shape, then one array must have a dimension that has a size of 1. Here we have 1 row, and here we have 1 column. So basically NumPy can apply this broadcasting. It first looks if they have the same size, same dimensionalities, and in our case they don't have same shape, as you can see. And then for second condition, it checks if anyone has a dimension size of 1. And here we have size of 1, here we have size of 1, so it can broadcast the arrays and apply this multiplication. Imagine that this becomes more longer. It looks like it stretches the array so that their shape sizes are equal. Because while you work with NumPy, you need to be very aware of dimensions of your arrays. And let me continue with same array. So I will continue with my array 1, actually, this one. Now I will apply some operations. We can print its sum easily without any for loop. NumPy is very useful with these operations too, like summing them up or finding means, variances, because it's faster. Okay, usually you need to do like for loops, while loops, you need to iterate through the array, and it takes big time and it's complex in terms of time. So NumPy can do this easily because it's written with C, so it's faster, also more readable, I think. Let me also print np mean array 1. Google Colab just suggests me some things so we can print them. Let me print them too. Also I want to print, yeah, that one too. Also I want to show argmax, also argument minimum. So let me run this. First, sum, of course, sums the list up very fast, very efficient, without looping through the array manually. Mean finds the mean, of course. Max tells you which is the maximum value. Argmax is, on the other hand, gives you the index of the maximum value. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it gives you 9 because the maximum element is on the 9th index. Minimum gives you minimum value, and argmin again gives you the index, which is 0. It's first index, 0th index. Finds the standard deviation, variance, find the variance, and this is a bit different. Maybe I can show you. I can cut it from here. Yep. We still have an array which has 2 dimensions, but now it has 2 rows and 5 columns. And now these are the same. These are still the same, but this one is different because when we say axis 0, it basically tells that use axis 0 while summing them up. So don't sum all array. Like the first one, we sum all elements, but when we give an axis, it sums like this: 1, 6, 2, 7. It goes like this. And you give, for example, axis 1, then it will sum the rows. First row is 15, the second row is 40. So you can basically like apply operations which axis you want very easily and efficient with this way with NumPy. Now we had an ages, I think, right? Ages. Yep. Let me take this. I want to apply some other operations on this one. Oh, you also have randomness in NumPy. You say random num generator, let's call it, np.random.default. This is your random number generator, okay? Then using this one, you can generate random numbers. Assign it to RNG, so you say RNG.generate random integers, and you can give a starting value and exclusive end value, so it can generate 1 but it cannot generate 10, and you can give it a size. Generate it. Let me print it for you to see number 1 and print number 1. It's generated 6. Now it generates 8, 5, and you can also have two numbers. And for number 2, let's give it a size. Okay, size, let me give it like this for 2 by 2. Now it will generate not a number but array. As you can see, now it generated an array with our size. If you don't give a size, its size is just a number. If you give size of 1, for example, then it's then again an array. But if you don't give 1, it's not even an array, it's just a number. And every time we have different numbers. But if you give it a seed, for example 42, then each time you run this code you generate the same number. But if you want complete randomness, then you can delete the seed and generate any number you want. And now we'll use our original array 1, and then this time let's do choice. This choice, you give array to it, and then you enter the size or number of variables. What it does is that it will go to array 1, which is this, and randomly chooses 4 elements in this shape. Okay, let me print this. I mean, it won't change anything, but I just want to write print. The array was looking like this. It just chooses, I mean, for this example, we didn't give any axis, and our array has 2 rows and 10 columns. So from 2 rows, it actually chooses 3 randomly. Okay, so as you can see here, it chose first row 1 time and the second row 2 times. To make it more clear, actually, let me create 1-dimensional array. This is our array, and let me print my array. Let's make it array 3. I don't want to lose my array 1 right now. This is our array. It doesn't have any row or column, it's just this. And then this thing, random, we use our random number generator, and we choose 3 elements inside this array to create new array. If we say 5, then it will create like 5. If we say 2 rows and 3 columns, we want this array. So you want to create an array from your existing array randomly, you can use this one. Okay, and then we have np arrange. This also creates new array, but instead of randomly choosing, you can say a starting point and then finish point, and then you have a step size. If you don't give a step size, by default it's 1, so this will create. Okay, now let me run this, but why do we get an error? Okay, I used double R, that's why. 10 is excluded again, and the starting point is included, and step size is 1. You can enter step size, for example 2, and then it won't print 9 because step size is 2. And then also we have np.linspace, and this is it's actually very similar to arrange, but the difference is instead of a step size you give number of elements and it divides the list. So here enter 11 so that we include 10, and let me run this. We wanted 5 elements, so it just equally divided numbers. If you want 3 elements, for example, it will put 5 because it wants to divide equally. You also have np nan imagine. You can say array 3 index 4, for example, equals np nan, and now you can print your array. Because this is integer. Okay, I can't convert float nan to integer. Do something like this maybe. I mean, I don't need to show you, I know, but I just wanted to print it out visually. I made all of the variables floats, and now as you can see, the 5 is none. Let me comment this. You have also inf for infinity. You can say, let me change one by one, okay? Actually, let me do something like this. This is the 0th element, and first, second is, let's use logarithmic function. The base is 10 and our number is 100, and you can do np exponential, for example. Okay, I think this is enough. Let me run this without shuffling. Whoa, because they are float, it looks very weird. Okay, But as you can see, first element is none. This is very complicated. It doesn't look very good. Okay, first element is none and second element is infinite. As you can see, these makes things very complicated. So okay, I can run them, but it looks very weird, I know. Why though? Oh, because we printed 2 times, that's why. Now it's more clear, I think. You also have sinus or cosine, so you can check them from the documentation and use them the way you want. And of course, let me create this again, or let me use array1 for this example. You can also, of course, append elements, insert elements, like you do in casual arrays. You also can do those in Numpy arrays. We want to append, for example, to this array, I want to add another array. Let me try to add this one. Let me call this array. Oh, we also have array 1, array 2. Let me call this array 3. New array 3. As you can see, it's just add these elements to new array 3, and now if you print array 3's shape, it changed. Okay, it's different than array 3 because it changed shape. It had a shape, what? Sorry, it had a shape of I just need to print them. 2 by 5 it had, now it has 13. So it changes the shape to 13 to 0 column. So it's still 2-dimensional, but now it has 13 rows basically. It flattens the array because we had a 2-dimensional array which is 2 rows and 5 columns, but we wanted to add 1-dimensional array to it. So it changed its shape to 1-dimensional, just 13 elements, and that's it. And this is our new array. It's 1-dimensional, as you can see, so it flattens the array to match the shape. Let me add some big numbers, okay, so that we can see more clearly. Okay, and now I want to add 2 rows. So now we are adding 2-dimensional array. It still flattens the array. Append works like this, so it changes its shape. It doesn't protect the original shape. You need to be careful about that. And we have also insert. And you have insert. Insert is different than append because in append by default you add elements in the last place, but now we can pick some index. When we try to run this code, it gives an error. Okay, because it couldn't add 0th index because let me print array 3 again. Because array 3 looks like this. It's 2-dimensional. This is actually the same sized array, just numbers are different, but it doesn't know how to add these two. So you have an axis. If you give 0, then you say add these on the index 1 row. And let me print this. We say add these like they are new rows and add them in the beginning. So our new array looks like this. If you pick 1, it will add these rows to the first index. If you say axis 0, now consider these as columns, and now it will give an error because it cannot add a column which has 5 rows like this. It's hard to explain without drawing, but we want to add columns. It has 2 columns, this has like 5 columns. So you need to delete items to match the size. Like this. And why do I have error? And now, as you can see, in the first index we added our new rows like this. I want to delete those, and we can say new array 3 np.delete, and let's say array 1, right? And the same array. If you enter 0, 0, the new array will look like this. Okay, because this is axis again. When we say axis 0, we say use rows for indexing. So we here enter 0 as row, same as insert, and deletes the first row, the 0th index row. But let me comment this out. we want to delete, imagine these two, because we added them accidentally. Imagine that. How do we delete them? We want to choose columns, right? Because we added these as columns. We want to choose these two. So choose 1, and as an index give 1, and then it will delete these two, 104 and 105. And what did it delete? Okay, it deleted these two. Okay, right, it's correct. Let me copy paste this here and here. I want to see the difference. It also deletes these two. Why? That's very weird. It should only delete 100. Because we delete from array 1 without adding. Now it will work. Okay. Because it doesn't change array 1. It just creates a copy of array 1. So we assign it to array 3. So we actually added these to array 3, not array 1. That was confusing. And now, as you can see, we can delete it. We deleted those. We can do this operation again. For example, to delete 2. Let me copy paste this and run. You will use these printing arrays shape, these functions occasionally. Probably you'll use them often because, as I said, shape is a bit complicated sometimes. You also have reshape function, basically change the shape, and you can create write the new shape, but you cannot enter, for example, 4 here, because then it doesn't know what to do. You had 10 elements, but with this one you can only have 8, and what will it do with the remaining 2 elements? The shape, the maximum number of elements should be match. Now we change the shape of the array. It's like opposite of it. We made it opposite. And as I said, while appending this or inserting, if you don't give an access, you may get error, or in appending, for example, it automatically flattened the array, right? And what do I mean by flatten? I basically mean it makes array one-dimensional. So let's flatten our array. Print array 3 flatten, and let's print its shape, new shape. What? Okay, sorry, I cannot print this. Okay, I need to assign it to show you. Oh, I forgot to put parentheses. Oh my God. As you can see, it looked like this. Its shape is 2 by 5, and now it's flattened. It's one-dimensional, and its shape is only 10. So flatten just flattens the array. We learned some shape changing operations, and I want to show you a bit more, just 2 more. We can also transpose our array, for array 3 for example, dot transpose, and now let's print its shape. I don't want to create a new copy. As you can see, transpose just changed axis by opposite. But if you don't want to like make opposite, but you want to change axis, then you can use swap axis. Swap axis, yes. And now you can choose which axis you want to swap. Now we only have 2 axes, so it will look same. It's again 5 by 2 because transpose just do opposite way, but with swap axis function you can choose which axis you want to actually swap. But since we have only 2 axes, it doesn't really matter for our example. And for our final function, you have concatenate. This kind of combines arrays. For example, let's create array 4, and let me change this a bit. I just want it to be 1 2 3 4. Or let's make this more simple. This is 1 2, and this is 3 4. Okay, I will concatenate this 2 arrays, array 3 and array 4. You will give arrays to this function, and then you will define access. But I made these one-dimensional. I want to make these 2-dimensional arrays. If you give access 0, then it will consider as row, so it will combine these. This is the first row and this is the second row, because it's how the order is. in our function. What? By the way, let me assign this. And we'll print a new array. Okay, array 5. But we have an error. Oh, I think, wait. Because concatenate, let me, in the syntax, perhaps you forgot a comma. Here I forgot a comma. I forgot the comma. The thing is, you can concatenate more than 2 arrays. That's why it accepts actually 2 parameters. It has 2 parameters, so you have to give it 2 arguments while using it. The first argument is list of your tuples or list of your arrays, etc. And the second argument is axis. Let me create another array. Array 6. It will be the same, but the only difference is we will change the axis. And now we will say it consider rows this time, columns. And now our new array look like this. So concatenate basically works like this. I think I covered the basics of Numpy. Of course, you can check the documentation, and these are very basic operations with 2-dimensional, 1-dimensional array. If you are into ML, machine learning, or data science, you will see much complicated things and harder problems to solve. Thank you for watching. See you on the next video.